Hello students, this is a video on the topic test by Bodhee Prep. These topic tests are quant-based tests. The idea of these tests is uh, once you have done the concepts of a topic and you want to check whether you're able to apply those concepts in the exam or not, you look at or you take these tests topic-wise. With every test, once you've written a test, there is a video that is attached that gives you the solution and a brief analysis of what could have been a good attempt in the test in terms of number of questions and time. There are more than 200 such tests available on the Bodhee Prep Android app. The link for the app is in the description of the video. So make sure you download the app and make the most of these tests. This video is about the topic logarithm, and this is the fifth test in the series that we're discussing. If we look at the questions or overall analysis for this test would be, I think this would be a difficult test in terms of level of difficulty. About 5 to 6 questions net correct would give you a 95 plus percentile, and attempt time for this test would be in the range of about 25 minutes tops. So this is the time in which you'll go through the questions, find our 5 to 6 questions, get them correct, and be done with the test. So yeah, that is the time that is required. If we look at the questions, question number 1 says log of n to the base x is the average of n, and log of n to the base x to the base x. Which of the following best describes n if x is 10? So log of n to the base 10 is the average of n plus log of 10 to the base n upon 2. 2 log of 10 to the base n is equal to n plus log of 10 to the base n. If n is equal to 1, this value will become 2. 10 raised to power 0 is 1. This would become log of 10 to the log. This value will become 0. If n is 1, log of 10 raised to power, this will become 0. And we'll have log of 0 to be found here. So n cannot be a value which is 1 or less, because then the log will not be defined. If we look at a value beyond 10, suppose n is equal to 10, in that case the left hand side becomes 2 into 10 to the base 10, which will be 1. Right hand side becomes 10 plus log of 10 and then log of 10 to the base 10. This will be 10 plus log of 10 to the base 1, which will be 10 plus 0, which is 10. Clearly, this is not equal. So as the value increases from 10, the value of n will increase very, very quickly, whereas left-hand side and right-hand side will increase very, very slowly. And therefore, the most likely answer will be a value between 1 and 10. I am extrapolating from the values and getting the answer. For me, this is a difficult question in terms of solving. And if you go on to solve this question easily, 2.5 3 minutes will be required. If the product of the roots of the equation x raised to power 3 by 4 into log of x to the base 2 square plus log of x to the base 2 minus 5 by 4 is root 2. The product of roots of this equation is 1 upon bth root of a, where a and b are natural numbers and value of a plus b is to be found out. So what we do is we take the log to the base 2 for this equation. The power comes down 3 by 4 log x to the base 2 square plus log of x to the base 2 minus 5 by 4 log of x to the base 2, right, is equal to log of root 2 to the base 2. Now what I'm doing is I'm replacing log of x to the base 2 by y. So this becomes 3 by 4 y square plus y minus 5 by 4. 5 by 4, not 5 by y. And log of x to the base will also be y. What will be log of 2 to the log of root 2 to the base 2? Root 2 is 2 raised to power 1 by 2. Log of 2 to the base 2 is 1, 1 by 2 comes forward, so 1 by 2. And therefore, 3 by 4 y cube plus y square minus 5y by 4 minus 1 by 2 is 0, multiplied by 4, 3y cube plus 4y square minus 5y minus 2 is equal to 0. And therefore, the roots that we'll get will be from here. If we put y as 1, 3 plus 7, 5 minus 7, y is equal to 1 will give 3 plus is one of the roots. So y plus y minus 1 into 3y square, 3y cube minus 3y square plus 7y square minus 3y square 3y cube minus 3y square plus 7 plus 7y minus 7y minus a plus 2 is equal to 0. So this is what we get. Further, y minus 1 into 3y square plus 6y plus y plus 2. Basically, what I've done is I put y here, y is 1 here, so that satisfied one of the roots. From there, we can either look at the sum of the roots and the product of the roots and get the two other values, or divide this entire thing by y minus 1, which gives us 3y square plus 7y plus 2. And then factorize this. So this becomes y minus 1 into, this is 3y into y plus 2 plus 1 into y plus 2, which gives us y minus 1 into 3y plus 1 into y plus 2 is equal to 0. So the value that y can take is 1 minus 1 by 3 and minus 1 by 2. So the product of roots will be minus 2 by 3. 2 by 3. Sum of roots will be minus 4 by 3. 6, 7, 3 minus 4 by 3. Minus plus. Minus plus minus. Okay. Now y is nothing but log of x to the base 2. So log of x to the base 2 could be 1. Log of x to the base 2 could be minus 1 by 3. Log of x to the base 2 could be minus 2. So from here x is 2 raised to power 1, which is 2. From here x is 2 raised to power minus 1 by 3. From here x is 2 raised to power minus 2. So x could be 2, 1 by 8, which becomes 1 by 2. Oh, sorry, cube root of 2, not 1 by 8. Cube root of 2. 1 by 2 to the power 1 by 3, and it could be x is equal to 1 by 2 raised to power 2, which is 1 by 4. If now we look at the product of the roots, it will be 2 into 1 by cube root of 2 into 1 by 4, which will be 1 by cube root of 2 into, this will be 1 by cube root of 8. 2 is basically cube root of 8, which is nothing but 1 by cube root of 8 2s are 16. This is given to be as 1 by bth root of a. Therefore, b becomes 3, a becomes 16, and therefore a plus b will be 19. Option D. Again, difficult question, easily 2.5 to 3 minutes to solve. There is a quadratic that the term in itself is a little complex. Then there is a quadratic with a cubic that needs to be solved, and then we are taking values of 2. Multiple chances of making a mistake or not being able to move forward. For a greater than 0 not equal to 1, find the number of ordered pairs x and y satisfying the equation. Log of mod of x plus y to the base a square is 1 by 2, and log of y minus log of x to the base a is log of 4 to the base a square. From here, in the first one, we can write x plus y will be nothing but a square to the power 1 by 2, which is a. So x plus y is equal to a. From here we can write log of uh, a minus log of b is log of a by b. So log of y by x to the base a is equal to log of 4 to the base a square. This becomes log of y by x to the base a is equal to 1 by 2 log of 4 to the base a. The power of the base comes forward. This is log of y by x to the base a is equal to log of 4 to the power 1 by 2 to the base a, which becomes log of y by x to the base a is equal to log of 2 to the base a. And therefore, from here we can write y by x will be equal to 2. So we get 2 or y is equal to 2x. X was in the mod, so we can put the mod again. Y is equal to 2 mod x, and therefore if we put y as mod of 2x here, we are making two cases. One, x is greater than 0, in which case we'll have x plus 2x is equal to a, which means x will be 3x is equal to a. X will be a by 3, which means y will be 2a by 3. When x is less than 0, we'll have x minus, this will open as minus x. So x minus 2x will be equal to a, in which case minus x is equal to a, or x will be equal to minus a. X will be equal to minus and y will be equal to 2a. Minus of mod x will give a, and therefore y is 2a. In both the cases, x plus y mod will open as a positive, so this mod does not need to be considered further in any case. So if you look at ordered pairs, there are two pairs possible: a by 3 comma 2a by 3 for x and y, or minus a and 2a. Hence, two solutions are possible, option C. In terms of level of difficulty, moderate to difficult probably. 2 to 2.5 minutes to solve the question. For how many values of a are x log a, comma y log 2a, and z log 3a in arithmetic progression? X, y, z, and a are natural numbers. So x log a can be written as log of a to the base x, log of e to the power x. Y log 2a can be written as log of a 2a to the power y. Log of 3a can be written as log of 3a to the power z. These are in arithmetic progression. Therefore, twice of log of 2a to the power y is equal to log of a to the power x plus log of 3a to the power z. For arithmetic progression, a plus b is twice of c, a plus c is twice of b. 2 again goes at the top. Log of 2a to the power 2y is equal to log of a plus log of b is log of ax into log of 3z az. We can now remove the log. 2 raised to power a to the power 2y is equal to a raised to power x plus z into 3 raised to power z, which can further be written as 2 raised to power 2y is equal to a raised to power x plus z minus y minus 2y, dividing both the sides by a raised to power 2y is equal to 3 raised into 3 raised to power z. 2 raised to power 2y, a raised to power 2y goes to the denominator, so x plus z minus 2y into 3 raised to power z. Now clearly, this side is a multiple of 3. For this equation to hold, either a has to be something which has a denominator of 3, so that the 3 cancels out, or the power of z or y have to be 0 so that everything becomes 1. None of the cases will be possible because x, y, z, and a are real numbers, or are natural numbers. Z and y cannot be zeros, and if a has a negative power, then it will have a denominator of 3. 3 will cancel out, but will not have 2 in the numerator. And therefore, these cannot be equal for any natural number power, and therefore, number of solutions possible is 0. Again, I'll call this a difficult question because solving it in the end becomes really difficult. And it's hard to say that there is no solution outrightly. 2 to 2.5 minutes to solve the question. The value of x satisfying log of 2 raised to power x plus x minus 41 to the base 10 is equal to x into 1 minus log of 5 to the base 10 is. So now I'm working with the right hand side first. This 1 can be written as log of 10 to the base 10 minus log of 5 to the base 10. This becomes x into log of a minus log of b is log of a by b to the base 10. Hence, this is x log of 2 to the base 10. Left hand side is, this can further be written as log of 10, log of 2 raised to power x to the base 10. Left hand side is log of 10, log of base 10, 2x plus x minus 41. So we remove log of 10, we get 2 raised to power x plus x minus 41 has to be equal to 2 raised to power x. 2 raised to power x, 2 raised to power x cancel. Therefore, x minus 41 is equal to 0. Or x is equal to 41 becomes my answer, option C. This, I think, is a relatively easier question. Max 2 to 2.5 minutes to solve. How many times do the graphs of y is equal to 2 raised to power x minus 1 mod and y is equal to 4 minus x square intersect? Now, y is same in both the cases. We can say 2 raised to power mod of x square minus 1 will be equal to 4 raised to power 1 minus x square, which means 2 raised to power mod of x square minus 1 is equal to 2 square into 1 minus x square. We're making two cases. Case 1, when x square minus 1 is greater than 0 or x square is greater than 1. In this case, we open the positive bracket. 2 raised to power x square minus 1 is equal to 2 raised to power 2 into 1 minus x square. Since the base is same, x square minus 1 is equal to 2 minus 2x square. Just removing the base, equating the powers, which gives us 3x square is equal to 3, or this will be greater than equal to 0, greater than equal to 1. X square is equal to 1. So if x square is equal to 1, we open the bracket as positive, and we get y is equal to 0. From here also, 2 raised to power 0, here also 4 raised to power 0. So one is x is equal to 1 will give us y is equal to 1. X is equal to minus 1 will also give us y is equal to 1, because x square is equal to 1 means x could be plus or minus 1. So we get two solutions here. The graphs will intersect at this point because at both the x's, the value of y is same. Second is case number 2, where we say x square minus 1 is less than 0, which means x square is less than 1. So here the bracket will open negative. Minus of x square minus 1 is equal to 2 into 2 raised to power 2 raised to power 2 into 1 minus x square. Again, the base is same. Base same, equating the powers. Minus x square plus 1 is equal to 2 minus 2x square. This will give us x square is equal to minus x square plus 1 is equal to 2 minus 2x square. 2x square comes with x square is equal to 1. Getting the same values. X square had to be less than 1. This also gives us the same value, and therefore these will be the only 2 points where the graphs will intersect. Again, solving for a quadratic equation with moderate question, about 2 minutes to solve. It is given that log of r to the base 6 plus log of 4 to the base 6 plus log of b to the base 6 is 6, where r is less than o is less than b are integers that form a geometric sequence. Progression o minus r is a perfect square, r plus o plus b is to be found out. Now, this equation can be written as log of a plus log of b plus log of c is log of a into b into c to the base 6 is 6, which means a into b into c will be 6 raised to power 6. Now, since these are three terms of an arithmetic progression, we can take the central term to be a, the first term to be a by r, where r is greater than 1, so r will be less than o, the capital R will be less than o, and this to be a into r. which means a by r into ar is equal to 6 raised to power 6, which gives us a cube is equal to 6 raised to power 6. Taking the cube root, a comes out to 6 raised to power 2, which is 36. The value of O is 36. R has to be such that when we divide 36 by R, we should get A by R, which is capital R, an integer, and similarly, here also we should get an integer when we multiply 36 by R. O minus R, that is A minus A by R, is given to be a perfect square, which is 36 into 1 minus 1 upon R is a perfect square. This is a perfect square. 1 minus 1 upon R should also be a perfect square then. Or if we take values, it will be better. If suppose we take values, O minus R is a perfect square. All of them are integers. Therefore, we can say O minus perfect square will be the value of capital R. O is 36 as we've calculated. Perfect squares could be 1, 4, 9, 16 or 25. 1, 2, 3, 4, 5. Cannot be 36 because R is less than O. In this case, R will be 35, 32, 27, 4, 16, 20, and 9. Now we know that R into O into B is 6 raised to power 6, which is nothing but 2 raised to power 6 into 3 raised to power 6. So R, O, and B should be divisible only by 2 and 3. 35, if we put R, it is divisible by 7, not possible. 32 is a possibility, 27 is a possibility, 4 is divisible by 5, not possible. 36 minus 25 is 11, that is a possibility. 32 is 2 raised to power 5. Now, if we put R as 2 raised to power 5 and O as 36 and B, we realize that 2 raised to power 5, 36 becomes 9 into 4, which is 2 raised to power 2. And therefore, the value of 2 becomes, the power of 2 becomes 2 raised to power 7, but it has to be 2 raised to power 6. So this is also not the case. We check for 27. If R is 27, B is 36, what will be the value? O is 36, what will be the value of B? We write 27 into 36 into B is equal to 6 raised to power 6 or 2 raised to power 6 into 3 raised to power 6. This becomes 27. 3 cube. 36 is 9 into 4, 3 square into 9 into 4. 2 square into B is equal to 2 raised to power 6 into 3 raised to power 6. 3 raised to power 3 plus 2, 5. So 3 remains. 2 raised to power 2 gives us 2 raised to power 4. So B will be 2, 4, 8, 16 into 3, that is 48. Hence, the three values become 27, 36, and 48. Therefore, R plus O plus B will be 48 plus 36, which is 84, plus 27, which is 111, becomes my answer. Again, this question I would say is moderate to difficult level, 2.5 to 3 minutes easily to solve this question. What is the product of the solutions of log of x to the base 243 minus log of 9 to the base x equal to 3 by 5? This can be written as log of x 243 is 3 raised to power 5. 3, 9, 27, 18, 243 minus log of 3 square x is equal to 3 by 5. This is 1/5 of log of x to the base 3 minus 2 let us keep 3 square as it is. X 3 square is equal to 3 by 5. Right, 2 here. Which means this is log of x to the power 1 by 5 to the base 3 minus this can be written as 2 upon log of x to the base 3. Log of 3 to the base x is 1 by log of x to the base 3. This is 3 by 5. If we put log of x to the base 3 as y and let the 1 by 5 be as it is here, we will get y by 5 minus 2 by y is equal to 3 by 5, which means multiplying by 5, y minus 10 by y is equal to 3, which means y square minus 10 is equal to 3y, y square 5 by y square 10, 3y, which means y square minus 3y minus 10 is equal to 0. Y is equal to 0. Y minus 5 into y plus 2 is equal to 0, which means y is equal to 5 or y is equal to minus 2. Now log of x to the base 3 is equal to 5 or log of x to the base 3 is equal to minus 2, which means x is equal to 3 raised to power 5 or x is equal to 3 raised to power minus 2. The product of these roots will be 3 raised to power 5 into 3 raised to power 2, which is 3 raised to power 5 minus 2, which is 3 cube or 27 becomes my answer. I think moderate level of difficulty, you just had to arrange with the same base and then solve about 2 to 2.5 minutes to solve. Find x and x satisfies 4x, 4 raised to power x plus 2 plus 2 raised to power x plus 1 is 3. Now this can be written as 2 raised to power 2x plus 4 because 4 is 2 square, so 2 gets multiplied, plus 2 raised to power x plus 1 is equal to 3, which is 2 raised to power 2x into, this is 4. 2 raised to power 4 plus 2 raised to power x into 2 raised to power 1 is equal to 3, which means 16 into 2 raised to power 2x plus 2 raised to power x into 2 is equal to 3. If we put 2 raised to power x as y here, we'll get 16y 2. 2 raised to power x is y, so this is y square plus 2y is equal to 3, which means 16y square plus 2y minus 3 is equal to 0. Looking for two terms which have a product of minus 48 and a difference of 2, we get 16y square plus 8y minus 6y minus 3 is equal to 0, which means 8y into y plus 1 minus 3, this is 2y, minus 3 into 2y plus 1 will be 0, which means 8y minus 3 into 2y plus 1 is equal to 0, which means y is equal to 3 by 8 or y is equal to minus 1 by 2. Clearly, y cannot be negative because it is 2 raised to power x. Therefore, 2 raised to power x or y should be equal to 3 by 8. Taking log to the base 2, we will get x log 2 to the base 2 is equal to log of 2 of 3, log of 3 by 8 to the base 2. So x is equal to log of 3 to the base 2 minus log of 8 to the base 2. Log of 8 to the base 2 will be 3. And therefore, log of 3 to the base 2 minus 3, or option A, which is minus 3 plus log of 3 to the base 2. I think moderate level of difficulty, this type of a replacement is something that you would have done while practicing and therefore would have been attempted about 2.5 minutes. If log of 2, log of base 2, log of base 3, log of base 7, log of base 15 of C is 13, then how many distinct positive prime numbers are factors of C? Now we can write log base 3, log base 7, log base 15 of C is equal to 2 raised to power 13. 2 raised to power 13 is equal to this part. Further, we can write log 7, log 15. Base C will be 3 raised to power this part. So 3 raised to power 2 raised to power 13. Further, we can write log C to the base 15 will be 7 raised to this part. So 7 raised to power 3 raised to power 2 raised to power 13. And therefore, the value of C will be nothing but 15 raised to power this part. So 15 raised to power 7 raised to power 3 raised to power 2 raised to power 13. Looks a little complicated, but this essentially is nothing but 3 raised to power 7 raised to power 3 raised to power 2 raised to power 13 into 5 raised to power 7 raised to power 3 raised to power 2 raised to power 13. We are not looking for factors, we're just looking for prime factors. Only two prime factors are possible, 3 and 5, and that becomes my answer. So again, might look a little difficult, but not more than a moderate level of difficulty question and should be solvable in about 2 minutes time. If we look at the overall test, probably a difficult test overall, 5 to 6 questions net attempt. A correct will give us a 95 percentile about in about 25 minutes time. The question that I would choose would be 3, 5, 6, 8, 9, 10. Which are these? Not doing this one in the exam. Similarly, this had a lot of arrangement to be done. Would have done this question. It was easier as compared to the first two. This again could not find a clear solution and therefore would have avoided this kind of a question. This I would have done in the exam was pretty straightforward. This one also had simple roots and therefore would have attempted it. Probably this one as well. Not very difficult to solve. Would have attempted this question as well. Just had to get log of x to the base 3 and then replaced by y. This I think was an easy question in terms of the other questions that were there. Again, this could have been attempted in the sense that we're just looking for odd factors. So for me, my attempt would be 3, 5, 6, 8, 9, 10. I think I counted the seventh question as well. Okay, yeah, this again you could have taken a look at this because finding O is easy. R could be a problem, so may or may not count this, and therefore 3, 5, 6, 8, 9, 10 will be a sure shot 6 question attempt for this test.